Here we go. All right. So, yeah. So, sine inverse of a half. I'll put parentheses. You don't have to have them, but sine inverse of a half. So, okay. How do we do this? How does this work? Inverse functions. Inverse functions. What do they do? That's an inverse function. Let's talk about what inverse functions first do. I hope you're dialing in with these. You know, we really are right now laying the foundations of trig. These first two chapters, super important. The basic graphs, this is a very important section if you want to go on to pre-calc and calc. You know, you really want to get these concepts because then they just keep getting used again and again. So come see me if you're having any trouble. I mean, I'm advertising office hours, 12 to 1, Monday, Tuesday, Wednesday. Glad to help. I'd love to do trig with you in there. And Roberto's hours. Get to help. Make sure you're mastering these things. Okay, so what's an inverse trig function do? Let's talk about before I get to that, let's talk about a normal trig function, and then we'll think backwards. Normally, you put the sine of something, right? Like, what's the sine of 30 degrees? How do we find the sine? Let's go to remember the unit circle? We could even do it without a calculator, huh? Sine of 30 degrees, how do you find the sine of 30? Well, you do the little circle thing, and there's 60, 45, 30. So the sine of 30 degrees, remember you go over and up, make a little triangle there. Remember how that works? It's over the large amount, up the small. You can tell it goes over, 30 degrees goes over a whole bunch, only up a little, right? Whereas the 45 is medium, and the 60 is over only a little, up a lot, right? Now what does that mean? Small, medium, large, right? I hope you're good with that from the last section of the course, chapter 1. Small is a half, medium is root 2 over 2, large is root 3 over 2, right? We just keep using those numbers over and over again, right? Root 1, root 2, root 3. You know, root 1's just 1, all over 2. So when I say it's over large, I mean it's over root 3 over 2. And up small, I mean it's up a half. And so what? What does that mean? Well, it's over that point. This dot right here is over root 3 over 2, up a half. That's its x and its y. And x is always cosine, remember? And sine is always y. For any point. For any point at any angle, cosine is always the x value. Sine is always the y value, right? So sine of 30 then is a half, isn't it? That you know, right? So I want to make sure we're solid on that, because now we're about to do the reverse. So I want to make sure you're really clear on the straight ahead. The sine of 30 degrees is a half. Now, what do inverse functions of any kind do? They reverse inputs and outputs. So let me give you something tangible. My favorite function example is a toaster. Right? A toaster's a function. We don't think about it that way, but it is. A function takes stuff in, does something to it, spits stuff out. So how does the toaster function work? You put in bread, push down the lever, a minute later, you get out toast. Right? Put in bread, get out toast. So you could say, well, you put in frozen waffles, you get out toasted waffles. So that's a normal toaster. Now there could be such a thing as an inverse toaster. Coming to Walmart this Christmas. Inverse toaster. How would if they advertise such a weird thing as an inverse toaster, how would that work? What would it do? What would an inverse toaster do?
Put toast in, get bread.
Yeah, put in toast, get out bread. It just rubs things backwards, right? Put in toast, get out bread. That'd be an inverse toaster. Why would you ever want that? Right? Well, maybe you make toast in the morning and then it pops out and you go, oh, I wanted to have eggs. That's right. Need a little more protein in my diet. Now I've made toast. You go, oh no, I got my handy dandy de-toaster from Walmart. Just put the toast back in the de-toaster, put the lever, turns it back into bread, put it back in the bag. It's all good. No, I'm just goofing around. But I want to help you remember, I do have a point, what an inverse function fundamentally is. It reverses inputs and outputs, doesn't it? Okay, so the same thing is true for all the inverse trig functions. What do we normally put into any of the sine, cosine, tangent, secant, cosecant, cotangent, all of them? We put in an angle, and we get out an answer, like a number, right? That's what we do for all the trig functions. You plug in an angle, could be degrees, could be radians, whatever. It's an amount of opening. It's an angle, right? And you get out an answer. So inverse trig functions, vice versa, switching inputs and outputs, which is what all inverse functions do, inverse trig or inverse toasters or inverse anything. So that means what? We plug in an answer, get out an angle, don't we? So that's the fundamental thought that needs to be in your mind when you're looking at any inverse trig function, inverse tangent, secant, cosecant, sine, cosine, whatever. You're plugging in an answer, getting out an angle. You're reversing inputs and outputs. That's what an inverse function always does, reverse inputs, outputs. Okay, so what? Well, so this half, when they ask me what's the sine inverse of a half, you need to look at that and go, oh, this is the answer. They're saying, hey, what angle sine produces the answer of a half? That's what they're saying. And you know the answer, huh? Because it says it right here. 30 degrees. 30 degrees is the angle whose sine's a half. You with me? Now, they probably want it in radians. Yeah, sure enough. They want radians. So how do you turn that into radians? You multiply. Remember, you put the 180 degrees down here, the pi, because pi 180 is the conversion, right? And then, so you get 30 over 180 pi. Reduce that. That's pi over 6, isn't it? So pi over 6 is the angle, same thing as 30 degrees, that whose sine is a half. Make sense so far? If you really get that, I mean, that's 90% of the battle. Just being really clear, what you plug in is an answer to sine inverse, or any inverse trig function. What they want out is the angle that does that. Okay. So sine inverse of minus a half. So you want to look at that and you want to say, okay, that's the answer. They want the angle, right? It's inverse. So minus half is the answer. What angle has a sine of minus a half? Well, you know what can help here? The first thing I would think, just remember the big three. The 45, the 60, and the 30, right? I would let me try to show you this in the easiest way possible. Just remember, have on your 3x5 card, remember part one will be, you do need to be able to do this without a calculator. There's going to be some calculator ones too, but I'm letting you know. In fact, I'll try to get that practice exam up early, maybe by the end of this week. I've already made it. I just need to put it up online for you. So I'll put up, so you can start looking at it ahead of time. I think that might be more helpful. So you have that practice time ahead of time. We'll have a formal day when we'll do it in a couple weeks, but less than a couple weeks. But anyway, so there'll be a part one, part two, just like before. Part one, no calculator. So you need to be able to do these without a calculator, but you do get your 3x5 card. So you can draw your unit circle, put your 30, 45, 60 on there. So you want to have those basic facts. You know this one is over root 3 over 2, up a half. That's cosine, that's sine. This one is over medium, root 2 over 2, root 2 over 2. This one is only over a half, up root 3 over 2. Again, that's cosine, sine, because x is always cosine, y is always sine. Have that on your card. And so then I wish I'd done that a little neater. Let me get a little room here, because that is important. That's really, really important that you have this. Let me make it neater. It's really, really important that you have this on your 3x5 card. This is root 2 over 2, root 2 over 2, and this one is over a half. Just write these, just like this. Cosine, sine, cosine, sine. There. Have that. That's about all you need. You can put 90 if you want. That's over 0 up 1. Again, cosine, sine for 90 degrees, Put 0, I guess. Whatever. That's enough. So have those on your 3x5 card, like that. And then you look and you go, okay, sine, and these are going to be a little tricky. You got to be able to do them backwards. Sine inverse of minus, you say, okay, that's an answer. Now, don't worry about the negative. We'll do the negative thing in just a second. Just think about the half first off. Where is the sine a half? Well, right here. Sine's a half, 30 degrees. So your first answer is basically it's 30 degrees, but I got to do something about the negative. It's not going to really be 30 in the end, but it's going to be like 30. So far, so good? It's basically 30 degrees. Now, it's not really 30 because it's negative. The sine is not negative a half at 30. It's positive a half. Where is the sine negative? Remember, all students take calculus. That's helpful for the signs. How we always handle the signs, right? All the trig functions are positive in the first quadrant. Only sine and his upside down cosecant are positive in the second. The other four are negative. Only tangent and his upside down cotan are positive in the third. The other four are negative. Only cosine and his upside down secant are positive in the fourth. The other four are negative. All right, so where's sine negative? All are positive. Sine is positive. These two quadrants, third and fourth. So we're talking here and here. Sine negative, sine negative. You with me? In the third and fourth quadrants, sine is negative, isn't it? So it's actually going to be one of those quadrants. Yeah, but it's 30 degrees. Well, it's 30 degrees reference angle in those quadrants. Remember reference angles? Reference angles, what is a reference angle? I hope you got that from the first. It's okay, I'm going to review it now. Reference. What's a reference angle? It's the angle from the x-axis. That's right. It's right, because this is 30 off of the x-axis. That's how we start. We started with the x-axis is 0, right? Because we started with the x-axis is 0 and measure all angles from the x-axis, therefore reference angles, meaning same angle in another quadrant, are always off the x-axis, not the y, because we originally made the x 0. So reference is off the x. So in other words, make a 30-degree angle off the x-axis in this quadrant and make a 30-degree angle off the x-axis in that quadrant. And they will have the same sine value, be a half, except it'll be negative, because sine is negative in those two quadrants, right? Sine will be negative a half, and sine will be negative a half. At 30 degrees off of that axis and at 30 degrees off of that axis in the third and fourth quadrants. When the reference angle is the same, the angle off the x-axis, that's what that means. You want to just know that. Reference angle, angle off the x-axis. If the angle off the x-axis, the reference angle is the same, 30 degrees, they're all going to have the same, all the trig functions, sine, cosine, tangent, all of them, will be the same except for the pluses and the minuses. And we know those because all students take calculus. So 30 degrees here and 30 degrees here. In both cases, the sine is negative a half. So there's two answers. Kinda. Not really. At first, there seem to be two answers, right? Both those places. And what are those answers, by the way? Like, what is this? I know it's right here. It's 30 degrees that, off the x-axis. But what is it from the start to there? Because that's really, we start really here at 0. That's got to be 210. Right? Because it's 180. It's 180 halfway around and 30 more. It's 210. That's really 210. You with me? It's my next class. They're loud, aren't they? So 210. 210. I'm sure they're talking about math. They're just really excited. I'm sorry, I'm just joking around. All right, 210 degrees. So everybody with me? That's 210. And what's this one? From here all the way to there. It's 330, right? Because it's just 30 off of 360. You with me on how I'm coming up with those two? So what we're really saying is 210 and 330. Those two both are 30 off the x-axis, reference angle 30. Their signs are going to be negative a half. So they're both valid answers. Yes, almost. Yes, almost. Here's the final kicker after all that information. We're going to throw this one away. Now, I don't have time to tell you why today, but we're only going to take the 330. Basically, the sign, we don't want two answers. Well, there's more to the story than that. But for now, we don't ever want two answers on these. So we're only going to take answers for the sine inverse, only quadrants 1 and 4. We only take answers from quadrants 1 and 4. I'll give you a whole chart for all of them to help you remember, and you put on a 3x5 card, so you don't need to make a big deal of it. So for now, I'll say the answer is 330 degrees. That's where the answer is. Let's go. Hey, we still have 2 good minutes. I want both those minutes for your math gain. Hold on. 330, we got to convert that to radians, so you know how to do it, right? So put the 180 down here and the pi up there. So that's 33, what is that? 330 over 180 pi. Reduce that somehow, and I don't know what it's going to become. 33 over 18 pi, reduced by 3. Is that 11/6 pi? After all, can you read all my writing? So I divided by 3, top and bottom. So I got rid of the zeros, 33/18. and then divide by 3. 11/6 pi. Your calculators will do that automatically, some of them for you. If you want just if you on your calculator you want to type in 330 over 180 and hit the fraction button, it'll just simplify it. 11/6. So 11/6 pi is the answer to that one. Does that make sense on that? What you see it